Before we move on to looking at how we can use phasors to solve circuits, I thought it would be nice to kind of summarize what we have learned till now. So we started off by looking at our current in this form, right? We wanted to know, we knew that our current will take a form of Im cos omega t plus phi. Okay. And therefore we said, okay, instead of giving an input in the cosine form, can we use the complex exponential so that it simplifies our circuit analysis a bit? So we went to this step. But once we reached here, we realized that this omega t term was just common throughout the equation and would get cancelled anyway later. So could we then ignore the omega t term right from the beginning and represent our current in this form? And this is especially valid because what we actually want to know is the change in phase and the change in amplitude. The frequency remains constant in linear time invariant circuits. Time invariant basically means that the circuit doesn't change with time. Okay, so for linear time invariant circuits, the frequency of the the frequency of the signals all throughout the circuit remains the same. So you may as well remove the omega t term and solve. But once you get here, you realize that Im e to the power j phi is a complex number, and there is another way of representing a complex number by just having the amplitude and the phase, and you essentially get rid of the e to the power j as well. Okay, and so we are here then, and this representation is the phasor representation. Either of these is called the phasor representation of the signal. So that's where we are. Now let's see how this helps us to analyze circuits. Just before finishing, I just wanted you to notice another thing, which is the fact that I have written the current here as capital I and the current here as capital I instead of I of t, because there is no time dependence in this representation, right? And just to avoid confusion and to make sure that you realize that these are phasor representations and these are phasors, so the time is there, but it is implicit and not explicitly stated. What I'm going to do is I'm going to put a bar above it, right? Remember when you wrote vectors, and if you have a vector f and you wanted to write an vector, sometimes you put a bar over it just to show that this is a vector and not a scalar quantity. In a similar fashion, let's just use a bar over the phasor quantities so that we don't get confused.